Today we're going to see in more detail how suspension systems work, how we make computer models of suspension systems and get the response, and how we design them. So on the screen you see in there, on the figure, there is a typical suspension system with the strut, and here where you can see the tire is here, and the central shaft is the rim is together with the parts over here, so that this is the becomes the main support, and that support is attached to the body of the car by this. It has this control arm, and of course it has a spring and a damper over here. So what I would like to do is maybe build this simple one and first understand how it behaves, and then we will look at the more sophisticated one. So excuse me, let's go to working model 2D, and let's just do a suspension system. Here we're going to go to a simple suspension system where we will put the ground maybe over here, and in here we are going to put a spring mass system over here, like this. Yeah. And you will say, well, this is a nice simple model. We should be able to analyze this no problem. And you can say, okay, I would like to keep track of the position of this. So you come in here and you define the or measure rather the position in the y direction is what we want. Okay, we could measure it in all the position in all y, x and y, and the rotation as well, but let's just do the y direction. And I'm going to do something that immediately will call your attention, because if I click on run and I want to see, perhaps I'll define also the vector, the velocity vector, to see what it does, velocity of the center of mass of this. So if I run it, watch what happens. Not very good engineer, right? And so obviously we need to tweak things in here. First of all, we need to put this fixed, and now we say we'll try it again. Not good engineer either. So the reason is that we need to define on how this suspension is going to work. The vehicle suspensions don't work with infinite degrees of freedom. They are constrained because they are attached to vehicles and they are designed to move up and down mainly. So what we need to do is to constrain the motion of this, and we are going to constrain it in the vertical direction to see how is it going to work. So we're going to do this key, this slot join in the vertical direction, and we're going to go to the center of mass of this and put it in there. So this will constrain for up and down motion. So now you see, this is more like it, huh? So this the suspension system behaves more like a real suspension system. Okay? So in here we need to let's see, we need to tweak in the values of this to if we want the suspension to be more the amplitude to be bigger, we could weaken this spring to half and see what it does. Yeah, and then we plot it again, and of course the damper also, it's, we need to change that too. This is the damper. Let's reduce this to half. 5, yeah, and see what happens. So we are getting a little more response, but I am not too happy with the plot because we don't see the we don't see it very well in here. So let me hold on for a second. So let's give it a test with some reasonable values in here, and we say run, and you will see that it oscillates, and of course it still oscillates, and it would eventually die down. Yeah, it will die down and finally settle. What we're interested, however, is that this would bounce about maybe one cycle, which is the normal design for a suspension system. So because we would like to change that, I am going to switch this damping to a little higher, let's say 5 in here, and see what it does. And then just so you have a reference, the mass of this is set right now to 5 kilograms. Okay, and if we run it, you see now it settles in much shorter time, maybe 2 cycles or so. If we really want to stiffen it out, the suspension in this case, so there would not be much oscillations, then of course we need to change the parameters. And I would keep increasing this to 8 now and see what happens, so that we would have a good idea what it's going to do. See, this is about 1 oscillation, and then you don't see them anymore. The point is that depending on how soft or how stiff the suspension should be, you will find a more you know, higher amplitude with lower values of the damper, and the frequency of oscillation would increase if we change the value of the spring. So that's the other thing that we should experiment, so that you can see if we increase K to, let's say, 60, and see what the effect is. We have seen the effect of the damper, but you can see in here that there's hardly any oscillation now, and perhaps we might need to, perhaps it's too stiff right now, and the spring might be too high as well. So the perhaps I'll go and do something dramatic. We could go the the other way and see where we get. Let's say this goes to a 20 here, and you should expect that this would go down more. Yeah, of course. See what it did with the weaker spring. We get this. So you can change the number of oscillations, and also you can change the amplitude. See, it starts here is like the springs are unstretched, And when we run it here, we go like this, see? So if we see, like I said, more oscillations or the amplitude change, we could go to the value of the damper. And if you go down again, let's say we reduce it this time and see what it's going to do. See? So now there would be much more oscillations until it settles down. So that's the way the two parameters, the spring and the damper, work in this case. So, but what I would like to see is if we implement this on a suspension system, let's take a look at another one that now is a little more realistic. We have put some parts over here um, for simulating the upper control arm, and another one to simulate the lower control arm. And this part would be the one that contains the hub, and the tire would go in here. Okay, so what we have in here is this position of this, and you have the velocity, and also you have the acceleration. And in this case, we have asked the the computer program to produce also the forces in that joint. So if I run, you will see what happens. Here's the operation of the suspension, and this is about right. This is about what you want. So in here we can have the value of the forces and also the velocities of the different points. You can see the velocities and accelerations until they stop. So in this case, if we want to look at the position of let's see, where are we here? We could take a look at the position over here and say if you want to measure the position there, and give me the sorry, let's try here. This will have measure the position, the Y graph. Okay, so okay, hold on for a second. Measure the position. Where is it pointing to? This one right here. Okay, I can have it in graph form. So if I run, you see what it's doing is giving me the Y position, the response, but also I can get the numbers. So that's how we can design the suspension. And you can see the response of the system when we change one or the other.